everybody. This is Mrs. John just taking you through today's lesson. So, what we're going to do today is if you take your booklets and turn to page 4, there are two things which we didn't do, I think, from memory because I don't have that written. We've done the rest of it. So, we're just looking at the last part of physical properties and uses of metals. Now, we're just going to do questions 5 and 6. So, electrical cables are made of aluminium because aluminium is a good conductor of electricity. Okay, so that's what we're going to write here. And then foil wrapping, so the foil that you use, it's not silver, that is also aluminium. Okay, foil wrapping is made of aluminium because aluminium is malleable. The word malleable means it can be beaten into thin sheets. Okay, so that's one part. And then the next thing that we're going to do today is the solutes and solvents experiment. Okay, you may not have everything at home, but we can do something. So this whole thing is before you begin your task, fill in the think what I think will happen. I don't worry too much about this. This one we won't do, but we can do the other things. Okay, so what we're going to do is we just need a rice grained size of whatever it is that we're using, and it says 2 centimeters of water. Now this is 2 centimeters of water in a test tube. What you could do is just use maybe a tablespoon of water. So just a tablespoon of water will do, and the quantity of your substance is just a rice grain, so it's just that much. Okay, and then you can put this into a cup or a glass. So just a little water and then a little bit, and then let's see what happens. So I don't know if everyone will have orange drink. Personally, I don't have orange drink at home, but we've got other things that might dissolve, which you can mix in water to make a soft drink or whatever, if it's possible. If you don't have any of those, try Milo, try instant coffee if you have. Or if you don't have any of these, anything that's colored, maybe just some sugar will do, just a little sugar. Okay, little brown sugar or white sugar, whatever you have. So put a little, and ideally in a lab, the way we mix things is by shaking the test tube. Now, I don't want to shake your glass and spill things, so just take a spoon and stir it for today and see what happens. So if it is orange drink, what's going to happen is that you will get it'll be orange in color. So the color would be orange. So what did happen was the orange powder would mix with water, mixes and disappears. You can't actually see the individual particles, and we call it the solution when you mix the water with the orange powder was orange in color, and it was clear. Okay, right. We won't do this one. Salt and water. So do the same thing with salt and water and see what happens to solution. We may not have starch at home, but instead of starch, you can try a little flour. You know what you use, just a tiny grain. Ask someone at home if you've got permission to do this, and do that. We won't do this one either because it's a teacher demonstration. So when we come back, I will show you how that happens. And the important thing is that it is not just water that dissolves things, lots of other things do as well. And it's not just solids that can be dissolved. You can have liquids and gases can be dissolved as well. Okay, so that's just an important concept. Okay, so that was page 4. Now we're going to just turn to page 5, the next page, and this one is about solutions. And what, even before you listen further to my video, just try and fill in the blanks as you can. If you can't, then watch it and just check your answers later. So often it is hard to tell that something is a mixture. Sugar in water is one example. The mixture is clear. The word clear means it's transparent and it's colorless. And the sugar seems to disappear. A mixture like this is called a solution. So you say sugar is soluble in water, so it dissolves. So these words are important. The sugar is called the solute and the water is called the solvent. So we say solute plus solvent will give rise to a solution. When sugar dissolves in water, its particles separate and spread out among the water particles. The separated sugar particles are too small to be seen, and so the solution looks clear. Now, what you have here is you initially put a little bit of sugar, the sugar crystal. It's got made of tiny, tiny particles, even though it looks just like one little crystal. And then the particles spread out, so you can see the particles spread out. And eventually, when you mix it, they spread out evenly. Okay? And different substances dissolve to different extents in different solvents. The solubility of a substance is a measure of how easily it will dissolve in a solvent. If a substance does not dissolve in a solvent, we say that it is insoluble. So that's the word, does not dissolve. When copper sulfate is dissolved in water, a solution is formed. The solution is colored blue, so you'll see this when we reach, and it is clear because you can see through it. The copper sulfate crystals are called the solute, and water is the solvent. The particles of copper sulfate can no longer be seen in the solution, so copper sulfate is soluble in water. When a solution is filtered, the undissolved particles, so what cannot dissolve, separate out. Okay, the rest of it goes through. Dissolving is a physical change because no new substance was made. Physical changes are easily reversible. But if you need to get back, in order to get back the sugar, what do you need to do to the water? You just need to evaporate the water. So if you evaporate the water, evaporate the solution, the water will evaporate, it will become a gas, but the sugar, which is solid, will go back to being a solid, and we'll be doing all this in class at some time. So that is today's work, and this is for Wednesday, the 18th of August, and I'm signing off.